All right, this is the property of exponents lesson. For any base b such that b is greater than 0 and b is not equal to 1, we have a couple properties. They're inverse properties. So the first one is you have log base b, and we have an exponential of that same base. Then what happens is they essentially cancel each other out and you're just left with x. So here's an example. Log base 10 of 10 to the 7th power will just equal 7. The second inverse is when we have a base raised to a logarithm of that same base. Then they cancel each other out, so you're just left with x. So an example, 10 raised to a logarithm of base 10 of 2, the answer will just be 2. Example 1. Log base 3 of 3 raised to the 11th power. They are both base 3. The logarithm is base 3. The exponential is base 3. So we're just going to equal 11. Second one, a little harder to tell because 81 is not showing right now as an exponential, but we can change that 81 to a base 3. So log base 3, and then 81 can be written as 3 to the 4th power. So what we're left with then is 4. Example C. The logarithm is the common log. The base is missing, so that's assumed to be base 10. And then we have an exponential of base 10. So the answer will just be 0.9. Example 2. We have an exponential of base 5 raised to a logarithm of base 5. So the answer is just 10. Example 2. We have an exponential base 2 raised to a logarithm of base 2. So we're left with just 8x. Example C. We have an exponential of base 10, and then we have a common log of base 10. So they are inverses of each other, so we're left with just 5. Remember that to multiply powers of the same base, you add the exponents. So this was in a previous lesson review. It's called the product of powers. So the bases are the same. That means then the exponents will just be added together when we multiply. This property can be used in reverse to write a sum of logarithms, exponents, as a single logarithm. Never leave a log in your final answer unless the directions say to write the equation in logarithmic form. You must simplify all your problems at the end with an answer in logarithmic form. So here is our property. So we have a logarithm, and it's of some base, and we're multiplying m and n together. We can expand that out into 2 separate logarithms. So here's what it would look like as 2 logarithms. Example 3, it says express logarithm of base 6 of 4 plus logarithm base 6 of 9 as a single logarithm. So the bases are both the same, so what we do is we multiply that 4 and 9 together using our property above. So here's our property. And we multiply them together. So we get log base 6 of 4 times 9. And then we multiply 4 times 9 together to give us 36. And then we see if we can simplify using prior properties, which we can. We can change 36 to an exponential. 6 times 6 is 36. And now these two are inverses of each other. We have a logarithm of base 6 and an exponential of base 6. We get the answer of 2.